So let me introduce what kind of devices we're using in this part of the experiment. So we have universal power supply, we have ECR power supply, then we have here ECR with the coils. Here we have oscilloscope, then different cables and multimeter. So before starting the experiment, this is very important to know which cables are connected to which one in case if some of them are removed. So let's start with the universal power supply. So in universal power supply, you have first maximum current, which is yellow cable. Yellow cable comes and connects to the top of the ESR power supply. Okay, so input, so top one here connects the top one to the ESR supply. Then if we go to the bottom one, the bottom one comes and connects to the bottom one of the ESR supply. Then we have here red cable, which is connected to the current plus and also to the yellow one, which is top one. Then we have a blue cable. So blue cable is connected to the bottom one, and then it connected to the this one, which is the max one, to this part. Then from here we have a ground from universal power supply, ground connected to the ground of the multimeter. Okay, then we have here the current, which is 20 amperes. It comes and it connects to the ESR, to the red one, so up here. Then after that we have this cable, the next to it, so next to it, which is connected to the coils, comes here and connects to this part. Okay, then we have here this, I think, BNC cable, which is connected to this part and connects to the HF output of the ESR power supply. Then after that, on this side, output one comes and connects to the ESR signal. Okay, then after that we have here output signal, which comes and connects to the channel 1 of the oscilloscope. Then next channel 2, it just comes and connects to the output of the right side of this ESR power supply. So this is basically all the cables are connected. So once we are confident that all cables are connected to its position as was shown in the manual, we have to now turn on all the power supplies. So this universal power supply is connected, then here ESR power supply is connected, and the oscilloscope is also turned on. Then what we have to do, you have to make sure the universal power supply is connected to the power supply is in 2 volts. Then after that we turning on the digital multimeter and we bring to the 20 amperes here. Then we increase the current to the maximum. Then we have to rotate, adjust the voltage in such a way that the current will be set to 1.3 amperes. Okay, then after that you press the bridge one, then you come here, the R position has to be in the center. Okay, then we have to adjust the oscilloscope. So in the oscilloscope part, first we have to play display, then we have to choose XY mode, which should be on. Then after that we have to press channel 1. Then after that, this should be coupling should be on the ground one, so F3 is ground one, so we select it. So for the X1 we selected for the first one we selected the coupling should be ground. For the channel 2 it should be Y direction, so Y selected. Then we press and should be DC mode. Okay, for the channel 2 we selected. Okay. Now for the sensitivity for the channel 1 we have to make it 1 volts. Okay, so the red one is 1 volt, and for channel 2 also make it 1 volt. Okay, so the yellow one is 1 volt. So basically if you look at here in the center, this division sometimes will be deviated, okay, from the center. So this one dot if I try to remove it, you can see it, that's the division, you can see it. So in the vertical position, try to center it to the exactly to the center. So when you put it to the center, this division, the red one becomes 0. Now what about the channel 2, which is the yellow one? So if it's again, it's on the upper or lower, again you have to play it, and in such a way you have to also bring to the 0. So as you can see, the channel 1 division is 0 0. This one is yellow one, channel 2, which is also 0. So after that you have to press from here. So it was initially it was on, but now you have to press this one. Then after that you press the channel 1. When you press channel 1, this is coupling is in ground, so you have to change it to the from ground to the AC, so DC, sorry. So you press DC and you will see such a thing. So then after that you have to play with C and try to rotate clockwise until you see a certain signal. Okay, so you can see some signal. Just a moment. So in order to see the signal better, we have to play with amplitude and increase the amplitude. Okay, then you can see such a signal. Then after that you have to play again with the C so that it will be symmetric. So let me play with it. So it basically has to, let me go back. So right now I can see such a thing, but again you have to rotate clockwise, counterclockwise to make it such a signal. Okay, so we are almost there. Okay, almost there. Yeah, so you have to see, make it more nicer. It should be exactly kind of symmetric. Okay, this is good. In order to see the signal even better, we have to change the channel 1 and channel 2 voltages. So let me put it to the 500, the both of them. So the channel 1 500 millivolts and channel 2, which is also 500 millivolts. And again you have to come here and play with C. Don't rush, so you have to make it more or less symmetric. Okay, after that we have to make sure that these two peaks will merge to each other. In order to merge these two peaks together, we have to play with the phase. So I'm rotating clockwise until they are merged, okay, to each other. So they are merged to each other, but right now we can see that it's shifted, so we have to somehow rotate to the left. So let me play with this one position. So I'm bringing to the center of it. Let me again play with it. Then we look at the digital multimeter here. And the digital multimeter, it's a little bit, change it. So let me put it back to here. So the resonant current is actually 1.25 amperes. So you have to take that note. You have also noticed, guys, that this digital multimeter should be far away, because if you bring it here, you can see the current is changing. Okay, it's very important that, because here is magnetic field is created from this coil, so you have to keep this digital multimeter far away from this ERC signal.